Welcome back to another episode of me making a game in Unity. Uh, Trying to make this village simulator game. Right now, I'm working on the AI. I'm using a goal-oriented action plan approach to the AI. We did quite a bit of, or originally with the villagers, and we're getting them to build things and move around. But that code was getting kind of messy, and then I came across this idea of this goal-oriented action planning system. And I've worked with a behavior trees before, and it's kind of like a behavior tree, only it makes these graphs dynamically based upon the actions, the world state, and different things. So that's what we've been working on, and don't take this as a tutorial because I'm not sure 100% that this will work or how it'll go. I'm not following a script or anything, but I do want to point out that a lot of this can be searched on the internet. As a matter of fact, Unity.learn has a really good tutorial on how to make one, and not only just make one, but understand how it all works. And so some of this might look kind of similar to how that is done, but I'm still trying to kind of just write this. I wrote the pseudocode and kind of write it myself. Um, so that's what I'm doing. And hopefully by writing it kind of myself, and what I mean by myself, it's not like I'm coming up with the idea of this, or even the idea of um, the script itself, because I've seen this algorithm in a couple different places, and they're all kind of similar. I mean, I think you're going to probably make it the same way. It's just I'm not going to do just copy line for line everything that's being done. More of uh, taking the ideas I've seen and seeing if I can just implement it myself. Um, which means probably what's going to end up happening. I'll have some errors and I'll have some mistakes, and I'll have to work through those. But I think this will just help me as a programmer to understand the system because I think although I'm really excited about the system, it is kind of a simple system. There's not a lot of scripts to get this to working. It's easy to understand, but then I think as I start working on this, there are tweaks and things I'm gonna have to do in order for it to work with what I'm trying to do in this game. All right, that being said, where were we? We were working on the graph, the AI planner. I'm actually starting with maybe the last script you would probably write for this, but it's the main thing that needs to be done. Um, this is the algorithm for creating the graph. Right now I'm working on this procedure right here, this method, and we got to a point, a kind of stopping point where we're creating the node for an action, and we add the cost to the action. Um, we're going to check the condition. We haven't written this, and what we'll probably have to do is send it the current the current states to it, so that um, so what this does is it checks actually not here. Uh, right here. We're going to check the condition of this action that we're currently looking at, and if it sends true, then we're going to add this action in our plan. If and I think we have to send it the current states. No, yeah, we're going to send it the current states so that we have a reference to that because we just don't want to look at the world because this current state is not only including what the current world conditions are, but what those conditions might be if a action takes place. All right, so then here, oh yeah, we haven't even written the script yet for the actions. Um, we could maybe, let's see if I can open up the AI actions. It will be mild behavior. We're just going to get rid of this for now. And let's see, in our AI planner, we need this. Can I do generate it? Yeah. Yes, no, maybe so. Now let me go to it. Oh wow, that was nice. Internal. I have not seen this before. We're going to just make it. I've never seen that word before. Internal. What does that even do? Internal? Has anyone ever seen that before? Okay, well, let's get rid of that. And we want to say return false as default. All right, so, and then we want to add this conditions and add the conditions to the states. I don't think we wanted to do it that way. How do we... Can we do a plus equals AI actions dot conditions? Let's see, we're going to go to our AI actions because it's going to have a public dictionary of strings and ints. And we're going to say we want to call this conditions. And actually, let's do a new dictionary. Can I, okay. Here's what we're going to do. Because I think we need to check this anyways. If for each key value pair, say string, comma int. We've seen this before, haven't we? We're going to loop through our dictionary. Whoop, I lost that. Key value pair. Yeah, key value pair of that. And we're going to call it key value pair. Sure. And we're going to call this the AI conditions. So we're going to get each of those value pairs if the current state that contains key of this key value pair, that key. Does that make sense? We're going to see if it's already there. If it's already there, then we're going to say current states dot current states this key value pair dot key plus equals to the key value. So we're going to add the value of it. Okay. Else, we're going to current states dot add key value pair dot key, comma, key value pair dot value. So what this does, if our if our effect, oh, so I don't want to say conditions, check conditions, add the conditions to the state. No, we want to add the effect. So let's go back to our AR action. So I'm basically going to just copy this, and we're going to say effects. All right, and let me go back here. So add the effects. This will loop through all the effects. Add to the current state if the effect is there. If not, add a new key / value. So if it's already there, add to it. And what I mean by add to it, it could be a negative. For example, let's say the world state already had uh, a resource on the ground that was in the, and this won't change the world state. This is just temporarily looking at the plan. If it already has the wood on the ground, and then we didn't, this action here says to pick up the wood, well then that would be like a -1 to it, right? So we're adding a -1, so then therefore it would no longer be on the ground. And so the next time we look at another action that says to, like, pick something up or whatever, it wouldn't be able to do that because there's no longer a wood on the ground for the AI to do that. Okay. If not, it's going to add this as a new part of the state. So then we, let's see if we do this. I don't like how I did that. Wait, did it? What did it do? Let me undo it. I don't even know what it did there. I went here, refactor, no new node. Okay, it changed all that. Now, we want to go to our action plan. We're going to have a public, I think I'm using ints for the cost. Okay. So then what it does is we're going to create a new node, and it's going to add the cost of this action plus the current node cost. All right. So then what's the next thing we need to do? Oh, I wrote a little pseudocode. So after we do this, we've created this node. We want to see, have we found our goal? So if, how do we do that? Okay, let's create, and really we could, let's take this out. I'm going to try to add more. We're going to just do a private void set current state, and what we're going to need is a dictionary of strings and ints. Call it conditions, or call it current states, and let's add a Let's add another dictionary, and we'll call it string, comma, int. I'm going to try to do this a little bit more with my code. Take things out and write methods for them. And I got to actually do it out here. So this is going to be the effects. And then let me take all this and put it in here. And instead of the AI action, we're going to say the effects. And instead of the current states, states. Okay. So that does the same thing. So now we're going to say set current, I'm going to call it current state. And we need a current states, comma, AI action dot effects. All right, and so then here, let's create another private right here. Private void. Actually, this give me a bool. Is goal met? I don't know. Sounds good, right? So is goal met? So here we're going to get the dictionary string int goals, comma, dictionary string int effects. So now in this one, we're going to test to see if all the goals are met by the effect. Right. I think that's right. So for example, the goal is that you want there to be a building built. So when you build a building, the effect would be building built. And so those would match up with that action. So getting to that action, find the action that satisfies the goal. Is goal met? We're going to say return false by default. So how do we do that? We need to for each key value pair, string comma int, and we're going to call this effects key effects pair in the effects. So if goals does not equal, if goals contains, contains key of the effects key, pair dot key, and if it does not, we're going to say return false. So return false, and maybe actually this will be true. So if we do not have this key at all, the goal is not met. Now else, how do we want to do the value? Let's just do this for now. If, whoops. So it founds the key in this case. Now we want to say if goals dot, I don't know, we can just do it like this. Effects dot pair dot value is less than 0. We're going to return false. Make sure there is a key, and then this one is, and this might change, but the value needs to be more than 0. Sorry, not more than 0, but let's say it needs to be more than 1. It needs to be more than 0. If the effect is less than 0, so it needs to be more than 0. If the effect is less than 1, it's going to be false. We might do some things like in the world state where if it's ever less than 1, it would remove that from the world states. But that's going to be just kind of a, it depends on what we end up doing with our game, because maybe we need some negatives. And that's why this might change. Maybe we need a goal that has a negative, you know. I don't know. So that should work. It goes through, it loops through all the effects. If it's not in the current state, see that this is saying we haven't met our goal. We haven't found an action that meets this goal. Because it's not in the world state, and then it's also less than 1. So right now, hypothetically, the state could still have that, but it was taken away. So then we go back here. If is goal met, and we need to send it our goal, comma, the AI action dot effects. Yes, no, maybe so. Oh, this is just goal. Okay, so if we found our goal, we want to return true. Do we need to send it anything else? One thing we need to do is nodes. Don't I have that? When we create the graph, we have a node. we want to send it a list. I thought I did this already, but maybe a list of nodes. Called nodes. So then return true. So right here we want to say nodes.add the new node. Um, Why am I saying this? What am I using this for? I don't know if I need this or not. That returns true. So, else, if it's not the goal, we're going to create graph. This is our recursion now. Because we haven't met our goal, let's add another node. Let's add another action here. Or add to the graph. I guess, yeah, that's fine. Create graph. We're going to say new node is going to be the node. Hold up. I did, yeah, the parent. This is the parent right here. On this shit. Yeah. We create the new node. We send it our nodes list. We available actions. Current available actions, comma, current states, comma, and our goal. Our goal won't change. All right, if we get to this point, hold on, what will this do? This is returning true. If we get to this point, do we want to return false? Oh, let me make sure. No, if we get to this point, if okay, if the action conditions is true, we add the effect. So if this wasn't, we don't want to return, or do we? Oh man, I'm kind of just trying to play this through. So we're looking at all the current actions. We came to an action that I don't think we do that here. I think if this action's not working at the current state, we would want to go to the next action in our loop. See, if I say return false, here we definitely want to say true because we got to an endpoint. We don't need to keep checking more actions. We've gotten to our goal. But here we don't want to. We want to say, okay, is there another action in our current available actions that would meet this condition? Okay, so I think that's right. But then if we've, see, I don't even think we need this really. So let's just get rid of that. Exit after going through all the actions. So that's, whoops. Yeah, let's exit. Exit going after through all the actions. That would be this. Recurse with the new node. That's right here. Loop through all the nodes and find the lowest cost. This does not happen here. Let me go up to here. This, we're going to have a public queue of IA actions. We need to give it a name. We're going to say create plan. Default will be return null. So that means we weren't able to find one at all. Alright, so loop through all the nodes. How do we do this? What does the plan need? It needs does it need an agent? And string comma int goals. Okay. Alright, so we need to do a start node. I could see there being an error. Let's say, no, it should be fine. If create graph, maybe we do need to check something else before that, but let's say new node or node start node is equal to new node and null for the parent. AI actions would be AI agent dot actions. Let's call it AI actions. Comma world state something. I don't know. It's probably going to be an I don't know. Maybe it'll be a static. We'll see. Comma. That's it, right? Just all the world states. So when we create a graph, we're going to say start node. Oh, here, we need a list of nodes call it nodes. We could call it graph. Graph nodes. Yeah. Equals new list. So start node, and then we send it the graph, which I need to spell correctly. Graph nodes. And we need to send the AI agent actions. Actually, hold on, this right here should be null, right? Can we do that? Well, we're going to find out. AI agent dot actions. Actually, we're going to call it AI actions. And let's just do that now. In my AI agent, we'll leave those because we might need them. We're going to say public AI list of AI actions, call it AI actions. It's equal to new list of actions. Okay, let's go to the planner again. Comma, and then our goals. Oh, I forgot the states. It's going to be the world state dot states. You know, I wonder, because let's say the AI agent has a public list, public dictionary of strings, comma, ints, and we're going to call this the beliefs. Because we kind of want to add that to the world states from the get-go, I think. And you see how we could use this same function to do that? I think so. Now, let's use it again. Right here, create, here, dictionary of strings, comma, ints is current states, which equals set current state, the world state, comma, the AI agent dot beliefs. So it would take all the beliefs and add them to it. If some of the beliefs anyways, we'll see. This is this might change based upon how we start actually implementing it, how this will work. Um, Parent action. Oh, we need a cost. Cost is nothing because it's the parent one. The parent one is null. All right. So if we find, and this is all, we haven't created that yet. Let's go to the world state, and maybe we make this not mono behavior. We just make it a static class. And we change this to a public static dictionary of strings, comma, ints, and call it the world states. And let me go to the AI planner. Let me go to the AI planner. Change this to world states. Mm. Hold up a second. Here, this is what we're going to do. We're going to copy that out, put this in, and we're going to actually call this a new one, a new dictionary. But we want to copy this just in case. And then we want to say set current state using the current states and the AI age and the AI beliefs. And then, so this will add all the beliefs to the current state. And then this should just be world states. Actually, this should be current states. And that way we're copying it. And this node should go here. And this should be the current states. So start node. Set up the current states for the world and the agent. Okay, so now what do we do? Now that, let's say this was true, we need to create our queue. How do we do that? Loop backwards. Okay, how am I looping backwards? This was something I'm trying to figure out as well. The loop back. We might have to do a while the start node, while, hold on, node cheapest is equal to a new node. All right, so our nodes have all these costs, correct? Man, I'm really trying to figure this out. Let's say it's creating all these nodes. Some nodes aren't complete. Other nodes are. I don't think I'm doing this right. I'm trying to go through the code because of this right here. And maybe I'm not thinking this clearly of how the algorithm works. Because basically what it's doing is looping through the action. So let's say the very first action, hey, it meets the condition of what's in the world. Okay, just something that's in the world. It meets the condition, right? But as it starts creating a path for this first action, it might never reach the goal is met, right? So we want to go to the next, it'll go to the next one. So this returns, what, we want this. We do want that found path. Found path is true. Public, oh, just bool. Bool path, we start as false. No, this is not right. See, when we first call the create graph, it sends it all the actions and it's looping through all the actions here so that this is the first call to it, the very first call. Somehow, and I don't know if we just need to have somehow when it gets to this point here, found path is true, return true. Okay. Well, what would it would return right here true? Correct. So do we need to do another if? Found path is true. And we want to return. Am I doing this right? Boy, oh boy, I know you're probably wondering the same thing. Uh, this is kind of what I want. I wanted to kind of do the code myself so I can understand exactly what it does. This doesn't need to return, does it? This is because we're in a recursion, right? We're repeating ourselves over and over again, so it does get kind of complicated. Yeah, I think so because this is going to return true and goes back to the last one. Oh, you found, we want to say found path was true. It returns it again. Found path was true. Returns again. Found path was true. Returns again. Found path was true. This needs to be found path. Does it? I feel like this is not right. And here's why. If we are looping through this one and we come to the very last action of the very first time we're looping through it, and that very last action never returned true, found path would say false, even though in our first one we did find it. So how do we how do we how does it know after it's gone through here? I don't know. I don't know. Because again, on the very first pass, it might have said true, but then on the very last path, because in hold on. Found path was true. I don't think so. I think this found path means we found a path to a goal. Because it could be that we have all these actions, and no matter what, we can't achieve the goal. No matter how we set it up, we can't that's the whole point of having it as a Boolean. Well, actually, I think this might be right. I think this is right. Because let's say on the first one, because each time we are returning, yes, true, yes, true, yes, true. So found path is true. Yes, we're returning true. So found path is true. Yes, we're returning it to the last one to where the very first one, it returned all the way back and it set the found path to true. So the first one sets it. Nothing else can change it back to false. So I think this is correct. And then we say found path. Okay. So how does this loop backwards to create the path? Okay. Okay. So how does it do that? Just to say node, current node, is going to be equal to this cheapest node. All right, cheapest node is equal to, let's see, for each node, node in where's our list? Oh, graph nodes. For each node in graph nodes, cheapest node, node, cheapest node, cheapest node. And here we're going to say just say cheapest node is equal to graph nodes 0. If node dot cost is less than cheapest node dot cost, then cheapest node is equal to node. Find the cheapest node, and then well, current node dot parent is not null. Oh, well, current node dot parent is not equal to null. So remember the very start. That means you've gotten to the start. Q what was our Q? Okay, let's just put up here. Q plan is equal to, sorry, we need to say AI actions plan is equal to new Q. And then we want to say plan dot add, or plan dot, I don't usually use Qs. Insert. There's not an insert. in queue. And we want to add the current node dot AI action. And then we want to say current node is equal to current node dot parent. I don't think this is correct up here. Like in my head, it doesn't, it finding the cheapest node, but I just don't think that's correct. Because the cheapest node is going to be the start node. It's 0. Although I don't think I ever added the start node to our list. So we need to do that. Graph nodes dot add. We need to add start node. So that's the cheapest one. It's 0. So I don't think we want to find the cheapest one, but we want to find the cheapest one of the ones that met the goal. Because those are going to be the most expensive ones. So maybe in our node, we need to say public bool is goal. And we're going to set to false. And we don't actually set it here, but then when we found the path with our goal, we want to say current node dot is goal is equal to true. And then up here, we want to find the cheapest angle. If node is less than the cost and node is equal dot is goal. And so really we don't want this. Can I just say this equals null? So actually we want to do this. If node dot is goal, if it is the goal, if cheapest node is equal to null, then the cheapest node is equal to this node. Else we want to check the cost. Return queue, return the plan. All right. I think that's kind of right. I mean, I really won't know until I can actually test this out, which we're kind of getting close to. I mean, we have all the things in place, except for we don't have our agent. We don't have actions. Like I'm gonna have to make some actions. I'm gonna have to have an AI agent kind of set some of those actions, set some of the goals, set some of the world states. Um, and one of the things I might need to do with our AI action, um, there's no way I can access this in the inspector. So I need to have some kind of other functionality that can this is model behavior. We basically could do public list of strings, call these condition strings, and a public list of ints, call them condition ints, and then public list of we do the same thing. And we call these, whoops, we call these effects. And then on like a public awake, we set our dictionary. So if I do conditions dot for each string, no, for I is conditions dot count, we're going to say conditions dot add this string, conditions strings dot I, comma, conditions ints, and this should be I. And then we would do the same thing for the effects. Effects string, effects strings, and this would be the ints. Alright, I'm going to save it. I think this, all of this right here, and actually this needs to be an abstract. Public bool, yeah. But we want a public, I think we call it virtual perform action. Whoops. Why doesn't it like that? Void. So it's meant to be overridden. And when we get closer to actually making some real things, real actions, so like in my AI actions, amazing we don't have any errors. Here I would do create a script, and we'll call it take take resource from ground. What we might also want in our actions, we might have a public string action name. And so that way, we can use that for testing. And this is going to take over an action, AI action. And we need to have a public override perform action. And in our start, we want to say base dot start. And we can't do that because this isn't public. Oh, this is AI agent AI. This actions public awake. Oh, I don't have a start. Public. I guess it doesn't. I think it'll run it anyways. Does it? um. So if we go to our villager, which we don't have one, but we do have one in our prefabs. So here we have where we could do our conditions, we could do our ints. So let's say we had a condition of on ground or on resource on ground, and the int would be 1. The effect would be has resource as a string, and this one would be 1. The cost, say 1, and the action would be take resource from the ground. Okay. I might save it here. I might continue this in the next video where we maybe try to start testing out how this is going to work, how the AI agent performs those tasks, and maybe just figure some other things out, because the action might also need, like, how long does it take? Kind of like what we were doing before with actions, saying a certain time that they would be working on it before it's complete. So we'll be doing that as well. All right, well, thanks again for watching, and I will see you next time. Bye.